Welcome back to the 8th session of Geometrical Properties of Section in Engineering Mechanics and Strength of Materials. Here in this session we are going to deal some problems related to the moment of inertia, which is L section as well as I section. Let's go to the first problem. In the first problem we need to find out the moment of inertia about x-x axis and y-y axis passing through the centroid of the unequal angle section whose dimension is 120 by 100 by 10 millimeter, where it stands on a 100 millimeter side shorter leg as a base. Let's get the figure. We have got the L section. In the L section, the bottom flange width is 100 millimeter, that is base, and the vertical height is 120 millimeter, that is the overall depth of the L section, and the overall thickness of the L section is 10 millimeter. Before going to find out the centroid for the L section, first we need to divide the L section into two rectangular section, that is at the base, that is 100 by 10 millimeter, we have to treat it as a one rectangular section, and 10 multiplied by the 110, because the overall depth is 120, deduct 10 millimeter, so we will get the total depth is 110 millimeter, which is rectangular section, second section. Now to find out the center of gravity of the L section, first we need to provide the reference axes. Let's get the reference axis. We have provided the reference axis at the base of the L section as x-x axis, and we have provided the y-y axis at the vertical left side of the L section. If we need to find out the x bar and y bar distances, we have to measure from the with respect to the x-x axis as well as y-y axis. Let's find out the center of gravity of the I section. By considering the first rectangle, first we need to find out the area of the rectangle, that is 100 multiplied by the 10 millimeter, which is width multiplied by the depth 1000 millimeter square, and the x distance, that is x1, from with respect to the y axis. As you can see, all the x distances which is measured with respect to the y axis, and all the y distances which is measured with respect to the x-x axis. Therefore, to find out the x distance, we have to measure with respect to the y-y axis, that is x1 is width divided by 2, that is 100 divided by 2, 50 millimeter, and y1 is the depth of the section is 10 millimeter, that is the depth divided by 2, which is 5 millimeter. This is for the rectangle 1. Let's get to the rectangle 2. To find out the area, first we need to consider the width, that is 10 millimeter, and the overall depth is 120. Within that we have to deduct 10 millimeter because we have taken here. So 110 millimeter is the depth of the section. So 10 by 110, that is 1100 millimeter square, and the x2 distance is with respect to the y axis is half of the width, that is 10 by 2, 5 millimeter, and y2 distance we have to measure from here to the x-x axis. So 10 plus half of the depth of the section, 10 plus 110 by 2, that is 65 millimeter. We have obtained the centroidal distance of individual sections. Let's find out the whole section centroidal distance as x bar and y bar. To find out the x bar, the formula is a1 x1 plus a2 x2 divided by a1 plus a2, where a1 represents the rectangle 1 area, x1 is centroidal distance with respect to x-x axis of the first rectangle, a2 is rectangle 2 area, x2 is centroidal distance of the second rectangle with respect to the x-x y-y axis. So here x bar is, if you substitute all the values, it is 26.43 millimeter. Let's go to the y bar. Here a1 y1 plus a2 y2 divided by a1 plus a2, area of the first rectangle, centroidal distance of the first rectangle with respect to the x-x axis, that is y1, a2 of the second rectangle, that is area of the second rectangle, centroidal distance of the second rectangle with respect to the x-axis axis, that is y2, and if we substitute all this value, we will get 36.43 millimeter as a x bar and y bar. Now we need to mark in the L section, that is 26.43 as a x bar, 36.43 as a y bar. So we got the center of gravity for the given L section. Now let's find out the moment of inertia for the given L section. To find out the moment of inertia for the given L section, we need to find out the moment of inertia for the first rectangle with respect to x-axis axis, that is b d cube by 12. The first rectangle width is 100 millimeter and the depth is 10 millimeter with respect to x-axis axis divided by 12. It's 8333.33 millimeter power 4. Here we need to find out the centroidal differences of the whole section with respect to the first rectangle, that is y bar minus y1, which is y bar is 36.43 minus y1 is, that is a centroidal distance with respect to the x-axis axis is 5 millimeter, so which is 31.43 millimeter. In the first rectangle, we need to find out the moment of inertia with respect to the y axis also. So the formula for the moment of inertia of the first rectangle with respect to the y axis is db cube by 12, where d is the depth of the section, that is 10 millimeter, b is the width of the section, that is 100 millimeter, 10 by 100 cube divided by 12. The formula, if we substitute it, the value is 33.33 into 10 power 3 millimeter power 4. To find out the centroidal distances of the whole section with respect to the y axis, that is x bar, and first rectangle, that is x1 with respect to the y axis is, x bar is 26.43, x1 is 50 millimeter, so we will get minus 23.57. Ultimately it is going to be positive because x bar minus x1 square is the formula. Now coming to the rectangle 2, the moment of inertia of the second rectangle with respect to the x axis is bd cube by 12, where the width of the section is 10 millimeter, depth of the section is 110 millimeter. Therefore the value is 110.91 into 10 power 4 millimeter power 4. Here for the second rectangle, the centroidal differences is y bar, that is the whole section centroid with respect to the x axis, minus second rectangle centroid with respect to the x axis, 36.43 minus 65, which is 28.57. Let's find out the moment of inertia of the second rectangle with respect to the y axis. The formula is db cube divided by 12, where depth of the section is 110 millimeter, width of the section is 10 millimeter, so 110 by 10 cube divided by 12, it is 9166.66 millimeter power 4. The centroidal difference along with respect to the y axis is x bar minus x2, which is 26.43 minus 5, which is 21.43 millimeter as a centroidal distances. To find out the moment of inertia about the centroidal x axis, the formula is Ixx, that is the moment of inertia of the L section with respect to the x axis, is equal to the moment of inertia of the first rectangle with respect to x axis plus area of the first rectangle multiplied by the centroidal differences of the first rectangle with respect to the whole section with respect to x axis square plus moment of inertia of the second rectangle with respect to x axis plus area of the second rectangle multiplied by the centroidal differences of the second rectangle with respect to the whole section with respect to the x axis square. If we substitute the value, that is Igx1 is 8333.33, A1 is area of the first rectangle is 1000 millimeter square, and y bar minus y1 square is nothing but 31.43 if we square it, and Igx2 is 110.91 into 10 power 4, area 2 is 100, that is 1100 millimeter square, y bar minus y2 whole square is 28.57 square. If we substitute all these and if we calculate the value of the moment of inertia along the x axis for the L section is 3.0031 into 10 power 6 millimeter power 4. Now let's find out the moment of inertia about the centroidal y axis. So the formula is, for the y axis, moment of inertia is first rectangle moment of inertia with respect to the y axis plus area of the first rectangle multiplied by the centroid differences with respect to the y axis, that is whole section minus first rectangle square plus moment of inertia of the second rectangle with respect to the y axis plus area of the second rectangle multiplied by the centroid differences of the whole section with respect to the second rectangle square with respect to the y axis. If we substitute all the value and if we obtain the moment of inertia of the y axis for the L section is 1.078 into 10 power 6 millimeter power 4. The unit for the moment of inertia is millimeter power 4. Now let's move on to the second problem. Here in the given problem we need to find out the moment of inertia of the I section, which is shown in figure, about the reference axis as OX and OY, which is passing through the bottom left corner. Here let's find out the OX and OY reference axis first. So we have given, that is OX and OY reference axis for the I section at the bottom left corner. So before that, rather than converting the I section into three rectangles, we have to first find out the XX and YY axis. Here if we see, if we provided the XX axis and YY axis at the center of the I section and the vertical side of the I section, it is exactly symmetrical about, since the I section is symmetrical about YY as well as XX axis. Therefore you can convert the I section as two rectangles, that is one total rectangle, total depth of the section, as well as another, the removed portion as another rectangle. Here if you need to find out the centroid of the I section, that is the width of the I section divided by 2 because of its symmetry, that is 100 by 2, and the total depth of the section divided by 2, that is 150 plus 10 divided by 2, that is 85 millimeter. And if you treat I section into a whole rectangle, the moment of inertia for the given figure is BD cube by 12, that is a capital BD cube by 12 minus small BD cube by 12, where we are treating the total I section as a full rectangle, that is a B, capital B is 100 millimeter, capital D is 170 millimeter, where within that the small b is, if we deduct 10 millimeter minus 100 millimeter, we will get 90 millimeter as a width, and the depth is 150 millimeter. Here they have given. So the moment of inertia formula for the IXX, that is, if we substitute capital B is 100 millimeter, capital D is 170 cube minus a small b is, the removed portion is, here it is a 45 and here it is a 45, that is a 90 millimeter, 150 is a depth of the removed portion. So we will get the moment of inertia directly here. To find out the moment of inertia of the YY axis, we have the formula for this two, that is 2 times the flange moment of inertia plus 1 time the web moment of inertia. That is, formula for the flange is, with respect to the XX axis is moment of inertia of the first section, that is a first flange, and this one is same, it is having the same dimension and the same depth. Therefore 2 times 10 is the depth of the section with respect to the YY axis, and 100 is the width of the section with respect to the YY axis divided by 12 plus Ig2y is nothing but moment of inertia of the second, that is the second web, where 150 is a width of the section and 90 millimeter is removed portion is a depth of the section. So here 10 is a depth of the section. 150 by 10 cube, that is a second section. So 150 into 10 cube by 12. So here we will get the moment of inertia of the y axis is 1.679 into 10 power 6 millimeter power 4. Next, we need to find out the moment of inertia of the about OX axis, where I have already told you we need to consider the I section as a old rectangle, that is a 100 by 170 rectangle. Within that, the removed portion we have to deduct 90 by 150 millimeter. If we need to find out the moment of inertia with respect to the OX axis is equal to moment of inertia with respect to the XX axis plus area of the rectangle multiplied by the y bar square with respect to the OX axis. So that is 15.629 is a moment of inertia, and area is a 3500 millimeter square, that is 100 into 170 minus 90 into 150, and y bar we have obtained already 85 whole square. So which is 40.916 into 10 power 6 millimeter power 4 when you consider OX axis moment of inertia. Now let's find out the moment of inertia about the OY axis. For the moment of inertia about the OY axis is moment of inertia related to the y axis plus area of the rectangle whatever we have considered and we have deducted multiplied by the x bar dimension. Here 1.679 into 10 power 6 is the moment of inertia with respect to the y axis, and area is 3500 and x bar distance we have already calculated, it is 50 whole square. So that is equal to 10.429 into 10 power 6 millimeter power 4. So this is the way of finding the moment of inertia for the given figure. Now we have added some MCQs. That is, first one is the radius of gyration of the rectangular section is proportional to, it is the square root of I divided by area. So square root of moment of inertia, square root of inverse of the area, square root of the moment of inertia divided by the area. So C is the answer. You can see square root of the moment of inertia divided by the area. The ratio of moment of inertia of a circular plate, that is a pi d power 4 by 64, and that of a square plate for equal depth. Square plate for equal depth, it is a BD cube by 12, that is a B power 4, that is D power 4 by 12. If we divide it, we will get the value which is less than 1. So I have done that one. Please go through that. The moment of inertia of a triangular section of base B and height h about an axis passing through CG and parallel to the base is, it's very clear that it's a BH cube by 36. Moment of inertia for the triangular section with base B and height h. The moment of inertia of the lamina about its CG, that is ICG. The value of the moment of inertia of a body about an AB parallel to the CG is given by the IXX plus area multiplied by the h square. That is IAB is nothing but ICG plus area multiplied by the h square, which is answer A. Thank you.